Chapter 2. Computer Languages. Chapter 7. Low-level languages, high-level languages, language translator. A program is a set of instructions which, when executed, makes the computer work in a particular manner. To write computer programs, computer languages are used. A program is written in a specific language called programming language. Computers do not understand any other language that we speak. They understand programs written in special languages. The process of designing, writing, and testing a program is called programming. A person who writes a program is called a computer programmer. A programmer writes the program in one of the programming languages. Computer languages can be categorized into two types. 1. Low-level languages. 2. High-level languages. Low-level languages. Machine language and assembly language are called low-level languages, LLL. Machine language. A computer can understand only special signals, which are represented by ones and zeros. These two digits are called binary digits. On state represents the binary digit 1 and off state represents the binary digit 0. The instructions in machine language are made of binary numbers. This makes the language suitable for the understanding of the computer, but more difficult to interpret and learn by the human programmer. Example of machine language is binary language. This language was called first generation language, 1GL. Assembly language. Assembly language was developed in 1950s. This language used words or names in English form and symbols instead of binary digits. These are also known as mnemonics. But as computer cannot understand the instructions written in any other language, a translator is needed to convert the assembly language program to machine language. This translator is called assembler. Programs written in assembly-level languages are called assembly codes. This language was called second generation language, 2GL. High-level languages. The languages of above generations were machine-specific languages. The next step in the development of computer languages was high-level language, HLL, a language that is quite similar to English language and is simple as well as user-friendly. These were called third-generation languages, 3GL. Examples of HLL are Pascal, Fortran, Basic, COBOL, C, C++, and Java. Advantages of high-level languages. Programs written in HLL are easier to understand and read. It is easier to debug a program in HLL. Programs written for one computer can run on a different computer. Difference between low-level language and high-level language. Low-level language, high-level language. Difficult to write, easier to write. Difficult to test, debug. Easier to test, debug. Processing speed is fast. Processing speed is slow. Modern high-level language. These languages are closer to human languages than the old-level languages. They are easier to learn and write. These programming languages are designed to reduce the overall time, effort, and cost of software development. These are also called fourth-generation languages, 4GL. Examples of fourth-generation languages are Python, Ruby, Perl, PHP, SQL, etc. Some of these modern languages provide a visual or graphical interface called a visual programming environment for creating the programs. These programming languages are designed to make the computer solve a given problem without the programmer. Thus, the user does not need specialized knowledge of programming. These are also called fifth-generation languages, 5GL. Examples of fifth-generation languages are Prolog, Mercury, OPS5, etc. Language translator. To make a computer understand a program written in high-level language, it is converted into machine-level language. This is done by a translator. A translator debugs the program and helps in execution. Working of translator. Once you execute your program, source code, the translator checks the syntax of your program to make sure the programming language was used correctly. It gives all the syntax error descriptive messages. You correct the errors and rerun the program to get a no error message. The translator then translates your program into a form the computer can understand, machine code. There are two types of translators. Compiler. A compiler searches errors in the entire program and lists them. If the program is error-free, it converts the code of program into machine code, and then the program can be executed. Interpreter. An interpreter translates the program into machine language, line by line, and checks the errors. If an error is found, it stops. Difference between compiler and interpreter. Compiler, interpreter, spends a lot of time analyzing and processing the program. Spends little time analyzing and processing the program. Translates program as a whole into machine code. Translates program one statement at a time. Generates error messages only after scanning the whole program. Hence, debugging is difficult. Continues translating the program until the first error is met, in which case it stops. Hence, debugging is easy. Program execution is fast. Program execution is slow. Needs more memory. Needs less memory.